Hi everyone, we're going to do a few examples on Hess's law. Remember, we are trying to obtain an overall reaction's enthalpy. So to do that, we take the sum of the enthalpies from each individual step of the reactions. So what you're going to want to do is look at what is the overall equation. Okay, here we have 2 sulfurs plus 3 oxygens will make 2 sulfites. Okay, so what I'm going to do is manipulate the step reactions to match what's happening in my overall reaction. Okay, the ways that you can manipulate these reactions is you're allowed to reverse the reaction. So the products will become the reactants and the reactants will become the products. Okay, when you do this, the sign of the enthalpy has to change. So if it was positive, it would now be negative, and if it was negative, it'd be positive. Okay. Another thing you can do is multiply a reaction so that the coefficients match. And basically, you're trying to create the step reactions to be equal to the overall reaction. So it does take some practice, but you just have to look at what is happening in each step reaction. Okay, so for example, for this first step reaction, I have sulfur plus oxygen makes sulfur dioxide. Okay, so looking at the overall reaction, I have a sulfur on the reactant side, but there's 2 of them. And I also have 3 oxygens and 2 SO3s. So for something like this, I'm a little bit limited in what I can do for the first step reaction. But I do know that I'm going to need 2 sulfurs. So what I'm going to do is multiply this whole equation by 2. Okay, so this will have a 2 coefficient, this will have a 2, and this will have a 2. And also, if you do anything to the step reaction, you're also going to have to do that to the enthalpy. So here I would multiply this by 2 as well. Okay, and that will be negative 594 kilojoules. Okay, for the second step reaction, we have SO3 as a reactant. But in the overall reaction, the one in the green box, the SO3 is a product. So what I can do is flip this reaction, or we can reverse it. Okay, when you reverse the reaction, you also are going to reverse the sign. So now this would be a negative 198 kilojoules. Okay, so I'm going to go ahead and rewrite this as a reverse reaction. Okay, so now let's see what we have. Okay, so once I flipped it, the sign changed. Now I can look to see if anything will cancel out. The way that things can cancel out is if they appear on the product side of one step equation or on the reactant side of another step equation. So this SO2 will cancel out. Okay, and if I combine both step reactions, it should equal the overall equation. So I'm going to combine everything I see on the left and everything I see on the right. So I have 2 sulfurs, plus I have 2 oxygens here, but I have 1 here, so that's a total of 3 oxygens. And I have a product of 2 SO3s. Now this is exactly what I wanted in my overall equation. So this is basically a puzzle. You know, you're allowed to reverse reactions. You can change the coefficients by multiplying them by some coefficient, but you're looking at the reaction as a goal to find what each substance is doing. Is it a product? Is it a reactant? And so on, until you get to what you want. When you cancel out a substance, it's because it appears on the product side of one and the reactant of another. So when you reverse a reaction, that's typically when you can cancel things out because they will get used up. Okay, so to get the final overall enthalpy, okay, we're going to add or find the sum of the step reaction. So this is negative 594 kilojoules plus negative 198 kilojoules, and that's going to equal negative 792 kilojoules, which is an exothermic reaction because we are losing heat in this equation. So let's backpedal and define what is Hess's law. So what I just did is an example of Hess's law, where you are looking at a combination of multiple steps that can be written as an overall chemical equation. And to get the total change in enthalpy, or delta H, you would have to find the sum of each individual step. So that's what we just did in that example. So how you're going to use Hess's law, you're going to look at the substances that you have in the overall reaction, okay? And you're going to manipulate your intermediate steps to essentially match the overall reaction. So you can, again, flip the reaction, meaning reverse it. You can multiply everything by some coefficient to get the coefficients to match. And when you combine the individual steps, if certain substances appear on the product side of one and the reactant of another, they will cancel out if they're on opposite sides. So it's really a puzzle, but we're going to do another example together. So here's this reaction. We have ethane plus hydrogen makes C2H6. So this is what I want. This is my overall reaction. And I'm going to try to manipulate the intermediate steps to match the overall reaction. Okay? So looking at the first one, we have C2H4 plus 3 oxygens, and so on. So because I have C2H4 here and C2H4 here, they're both on the reactant side. They don't have a larger coefficient than 1. The coefficient is 1. I don't need to multiply it by anything, and I don't need to reverse the reaction. So I'm just going to keep this the way that it is. So we're just going to keep this. For the second intermediate reaction, we have C2H6 as a reactant, whereas in our overall equation, it is a product. So that is a telltale sign that you're going to have to flip or reverse the reaction. So we're going to end up flipping this guy. When you flip this reaction, the sign will also change. So this would be positive 1560 kilojoules. Okay. For the third reaction, we have hydrogen as a reactant, and this also looks okay. I don't need to multiply it by any coefficient, but here hydrogen is a reactant, and here hydrogen is a reactant. So I'm also going to keep that the way that it is. So the one that I flipped, normally I rewrite these. It helps you guys see what's really happening. So I'm just going to rewrite this guy down here as the reverse. So I'm going to make these the reactants, and then the other side the products. Okay, so I'm just gonna blacken this out just so it doesn't distract us and we can focus on everything that we're doing. Okay. So to find my overall reaction, I want these to match. So let's see. Does anything cancel out? So we have carbon dioxide here, and we have carbon dioxide here. If it appears as on opposite sides, you can cancel these out. For water, we have, let's see. So we have 3 waters here. We have 2 plus 1. So that's 3 waters on the product side. And then we also have 3 here. So that's 3 waters on the reactant side. So all of these are going to cancel. For oxygen, I have 3 here, a half here, and then I have 3 and a half here. So those are all going to cancel because they're on opposite sides. So what we end up doing is just bringing down everything else that didn't cancel out. So we have C2H4 plus H2 yields C2H6. And when we get the final sum, we're going to add up everything that we did based on the changes that we made. So since I didn't manipulate the first and second intermediate reaction, all I did was change the second one. We would just add up everything. So it'd be negative 1411 plus 1560 plus negative 285.8 kilojoules. So my total change in enthalpy for this reaction is negative 136.8 kilojoules. And that is how we use Hess's law.